Hey everybody, welcome to my Hot Wash. Today we're going to take some time to talk about the phosphoinositide signaling pathway. This pathway is really important to keeping us alive and making sure that our downstream signaling effects occur so that our body can carry out all of its required cellular functions, reactions, everything like that. Our first picture here is just a general pathway. We're not going to go all the way through everything because that would just be way too much and way more than we need to know. But some important things to point out here is that we have our GPCR, which is signaling to activate our PLC, which goes to DAG and IP3. And then you can see the downstream effects down here. We'll cover this more later on. So let's take a quick second to review our signaling pathway. So we're going to start off by binding a ligand to the GPCR receptor site. From there, the alpha subunit is going to break off. A GDP is going to be replaced with a GTP, and the alpha GTP complex will leave the subunit. This activated subunit then goes on to further phosphorylate downstream target molecules such as the phospholipase C. Okay, so once we've activated our GPCR, we'll then phosphorylate and activate our phospholipase C. An important thing to note here is that a big mediator for this is going to be your catecholamines, epinephrine and norepinephrine. Once your PLC is activated, it's going to cleave the phosphatidylinositol bisphosphate molecule, you've seen here, into our two products. We have the cyclic IP3, which then becomes IP3, and then our second product is DAG or diacylglycerate. Okay, and then once we've finished making our products, which are again DAG and IP3, we're going to move on to secondary signaling. So the role of our secondary signaling here with DAG is to create both protein kinase C and protein kinase D, which are very similar. The big difference being that protein kinase C is responsible for gene expression, whereas protein kinase D handles more vesicle traffic. The goal for DAG is to promote the kinases that help us, help our cells grow, help us survive, everything like that. I also went ahead and included just a 3D representation of protein kinase C. So you can kind of see that it has both the alpha helices as well as the beta sheets that help to form its overall tertiary structure. For IP3, the biggest role about this one is that it will release calcium from the ER. So calcium, as we know, is a very important messenger. It handles almost all the body systems. It has roles in the digestive system, the cardiovascular system, the nervous system, and then its very big one is that it will activate protein kinase B. Protein kinase B is going to be activated by both IP3 from calcium and calmodulin. And then this will allow it to do things like mediate apoptosis, move our GLUT4 transporters, handle insulin receptor signaling pathways, help us synthesize glycogen, regulate the cell cycle. It's really a bunch of features that are very, very critical towards survival and making sure that we are able to carry out the mission critical reactions. So now I'm going to take a second to talk about an important role that PLC inhibition in cancer treatment can have. So many of the pathways, as we talked about, relate to the ability to regulate the cell cycle, regulate cell survival, growth. And so they're a really great point to kind of introduce, chemotherapy and anti-cancer treatments. So one anti-cancer treatment that's coming onto the market now is adelphosine. And this is used to inhibit the PKB pathway, which will, essentially help to make sure that the cell is not able to survive and kind of just slow the cancer growth. They've also found that the addition of adelphosine to the cancer cells will actually induce apoptosis without targeting the healthy cells. And so we're able to see a high degree of specificity within the medication, making it a great beginning to a new type of cancer treatment that we haven't quite seen before. All right, so now we're going to take the last 30 seconds or so just to go over big picture, what you need to remember, most important things we have with our PLC signaling pathway. So first up, we have our ligand binding to our GPCR. That's something like your catecholamines, your signaling molecules, anything that's able to get to that site that's specific for that receptor. From there, the GPCR is going to activate the PLC. The PLC is going to cleave that one giant molecule into two smaller ones, both DAG and IP3. From there, IP3 will release calcium ions from the endoplasmic reticulum, and the calcium ions then go on to promote PKB, cell regulation, everything like that that's critical to cell survival. And then DAG then goes down the road to activate PKC and PKD. The PKC is going to help with cell growth, gene expression, and PKD is going to be important for cell growth and vesicle traffic. And that's it. If you have any questions, feel free to reach out. I'd love to answer them. Thank you for watching my hot wash.